is my lecture recap for Thursday the 23rd. We started lecture with a recap on the heart's anatomy, which I'm choosing to include as it is necessary to understand the rest of the lecture. Here we have a cross-section of the heart. The thickness of the white line surrounding the heart throughout is representative of the thickness of the muscle tissue in the heart. Clearly, the left ventricle's wall is larger than any other spot in the heart, and this is due to its aid in pumping the blood to the rest of the body. The green line here separates the atrium and ventricle of both sides of the heart. This is made of fibrous tissue and aids in preventing backflow through the valves. Moving on to blood flow. The blood will enter the right atrium via the superior and inferior vena cava. This blood is then pumped through the tricuspid valve into the right ventricle. It is then pumped through the pulmonary valve out the pulmonary artery. Into the lungs. Upon returning to the heart, the blood will enter the left atrium via the 4 pulmonary veins. It is then squeezed through the mitral valve to the left ventricle, then out the aortic valve into the aorta. The pumping of the blood in this order with no backflow is done via the cardiac muscles, nodals, and contractiles. Nodals have very few myofibrils inside, but are important in stimulating the contractile muscles that are filled with myofibrils to contract. It is important that the heart maintain the lub-dub pattern, and this is done so via the SA and AV node, as well as all the nodals that surround the heart. Moving on to the next diagram here. The nodals are going to be here represented in blue. The thickness of this line once again represents the abundance of the nodal cells. They surround the heart and are constantly moving electrical impulses down them. It is important to note the direction of the alignment of the contractile cells in different parts of the heart in order to understand how the heart contracts. For example, the contractile cells in this part of the heart would come at an angle here, while down here they would move in such a way and this is similar completely around. The impulses will start out here on the atrium, allowing them to contract first. The impulses will then go from the SA node to the AV node that is found on the septum of the heart. The AV node has less gap junctions than the SA node, which results in the delay of impulses in that lub-dub sound the heart makes. The impulse then moves down the septum more densely to the left and causes the contraction to go here. The impulse then moves on to the ventricles and allows them to push the blood out of the heart. Once again, the left side a little more dense because the blood must reach the entire body, and the final contraction spreads back up the sides and contracts out here before eventually starting all over again. So numbering 1 would be here, the second impulse would go off here, the third would be the ventricles, and the fourth would be the sides of the heart here. And that is all for the recap today.